Hi guys, this will be an extra practice video of solving exponential equations. So if you haven't seen the previous video covering how to go about solving exponential equations, make sure you watch that video before trying this one. Alright, so let's get right into this video. So notice that I have an exponential that I'm trying to solve for. My variable is where the exponent is. So the first thing you want to do here is you want to isolate the exponential. So in order to do that, I want to isolate this guy right here. I'm going to want to divide both sides by negative 4.1. Okay, so I'm going to go ahead and do that. So I'm going to do negative 79.1 divided by negative 4.1. Okay, and I get an answer of 19.29. So what I have here now is 14 to 1.2k equals, and again we just divided both sides by negative 4.1, we got 19.29. Okay, so now remember your rules. We want to try to get the same base here when we're solving for exponentials. So we want to try to get the same base between both of these values that we have on the left and right side of the equal sign. Well, if you look at this, that's not going to be possible. So your next option is to take the log on both sides. So we're going to take log on both sides. So when we do that, we get log, and we get 14 to 1.2k, and then we get log 19.29. And remember, when we have a log, this goes back to the power property of logs. When we have an exponent, it simply comes down to the front. So we can rewrite this as 1.2k log 14 equals log of 19.29. Okay, now we just want to try to isolate this k, so there's a couple of things we need to do. First, we're going to divide right here by a log of 14, so we want to divide both sides by a log of 14, cancels here, log of 14. So let's go ahead and put this into our calculator. So we get log 19.29 divided by log of 14. Right, and we get 1.12. So now we have 1.2k equals what we just did here, and we said 1.12. Okay. Very simply now, just divide by 1.2. So when we do that, our final answer here is going to be 0.93. Right, so we can put 0.93. So k equals 0.93. And that's our final answer. Okay, let's try some more. Let's go ahead and erase this guy. Let's mix it up a little bit. Let's do this one. So if we have 32, negative 2, and minus plus 3 equal to 4 to 1 minus 3n. Alright, so what you want to do at this point, you want to try to get the same base, right? We have an exponential on both sides, and we want to try to get the same base. And again, we covered why you're trying to get the same base, because they'll cancel out. And again, they're canceling out because of the properties of inverse logs. So let's try to get the same base here between these two. Well, it looks like I can use a 2 here, because 2 to the 5th power is going to be 32, and 2 to the 2nd power will be 4. So I can rewrite this now as 2 I'll write it like this, to the 5 equal to 2 the second, and then we have 1 minus 3n. So again, we're dealing with the same base here. And remember, they're going to naturally cancel out. Just to refresh in case we forgot why, these bases will cancel out because if I take log base of 2 on both sides, okay, so if I were to do log base 2 of 2, and then I have this 5 negative 2n plus 3 equal to log base 2, 2 to the 2, 1 minus 3n, okay? These will naturally cancel out because this is inverse logs, right? That's a property of inverse logs. They'll naturally cancel out. That is 1, okay? So that is why they're canceling out. So when you have the same base, you can simply just cancel them out, and this is why. Right. So let's go ahead and cancel these out, and we're left with, well, 5 times a negative 2n is going to be negative 10n, and then 5 times 3 is going to be 15. 2 times 1 is 2, and then 2 times a negative 3n is negative 6n. Okay, so this is just simply algebra now. We need to just isolate that n. So let's add 6 on both sides. Alright, so we got a negative 10n and a positive 6n, so that's negative 4n. Alright, and then let's subtract 15. So we have a positive 2 and a negative 15. So we know that is going to make a negative 13. Right? And now at this point, all you have to do is divide by negative 4. Okay? And two negatives, when we divide, make a positive, so our final answer here is n equals 13 over 4. Okay, and that is our final answer. Alright, let's try a few more here. So let's do, next one, let's do 9 times 10 to n plus 8 equal to 81. Right. So the first thing you want to do here is you want to isolate your exponential. So in this case, you want to isolate this 10 to the n plus 8. In order to do that, I'm going to have to divide both sides by 9. So let's go ahead and do that, divide both sides by 9. So we get 10 to the n plus 8 equals, well, this will be 9. Alright, so we want to see if we can get the same base here. Well, with this problem, it doesn't look like we're going to be able to. Alright, so simply we're going to take the log of both sides. So we get log of 10 to the n plus 8 equals log of 9. Right? Well, based on our properties of logs, in particular, the power property, we know that this right here, our power, will come down to the front when we're dealing with logs. Okay, so this is going to be n plus 8, and then we'll get log 10. And now we have equal to log 9. Alright, so at this point, all you want to do is divide by log of 10 now. Alright, this cancels. So let's go ahead and do this. Log 9 divided by log of 10. So log 9 divided by log of 10. We get 0.954. Alright, so now we have n plus, and we just did this out and we said it was 0.954. 0.954. Now you're simply just going to subtract 8, and when we do that, our final answer is negative 7.04. So n equals negative 7.04. Okay, sorry, that's a 4. So negative 7.04. Alright, let's do one more problem here and that will be it. So negative 7.04. Okay, let's do do the next one here. Here's a good one. So if we have 1 over 625, this is negative 3n equal to 5 to the third power. Okay, so you want to go and see if you can rewrite this as the same base. Well, I have 1 over 625. Okay, 1 over 625. So what is that really saying? How can we rewrite this? Well, we can rewrite this guy right as, what if we did this? 1 over 5. Now 5 to what power will give me 625? Again, 5 to what power will give me 625? Well, that's going to be 4. Okay? Alright? And we know that we can rewrite this as, we have 1 over 5 to a power, we can rewrite it as 5 to the negative 4, right? Times negative 3n equal to 5 to the third. Alright, so just to confirm here, so we're on the same page, 1 over 5 to the fourth power is the same thing as 5 to the negative 4. Okay, that's based on your properties of exponents. Okay, so let me just leave that up there. So we know 1 over 5 to the fourth power is the same thing as 5 to the negative 4. Alright, well here we have the same base, so we can simply cancel this out. And let's just do this out. So a negative 4 times a negative 3, that's going to be positive 12n equal to 3. Okay, and at this point, all we want to do is divide by 12 here, so we get n equals 3 over 12. And we can reduce this. 3 goes into itself once, and 3 goes into 12 4 times. So here is our final answer, 1 over 4. Okay, so that is solving exponential equations. This was an extra practice video.